now going to learn how to solve system of equations using matrices. Suppose you wanted to solve x plus 2y equals 3 and 2x plus 3y is equal to 5. Well, the first thing you do is you make up a matrix. This is understood to be 1x. Basically, to make up the matrix, you erase or delete or not include the numbers. I meant to say the variables. You do not include the variables. And plus 2 is just 2. Okay, don't include the variables. Plus 2 is 2, and plus 3 is 3. You just put down the coefficients. If it was minus 3y, I would put down negative 3. And one last thing, where the equal signs are, you put a line. This top line reads 1x, and this is understood to be positive 2, 1x plus 2y equals 3, or x plus 2y equals 3. 2x plus 3y equal to 5. If you had 1, 3, 5, 2, so that means the variables are x, y, z, and 2 zeros, 3, 5, and 1, 2, 3, 4. 1x plus 3y, let's make that minus. 1x plus 3y minus 5z is 2. 2x. Now adding 0 y's, you don't need to do. 2x plus 3z is equal to 5. I changed the last line. 1x minus 2y minus 3z equals 4. Okay, I'm just not writing down the x's, the y's, and the z's. And 3 is positive. 3 is positive. 0 is positive. Equals, equals, equals. So that's the first thing you need to know how to do. How to go from the equations to the matrix. It's called an augmented matrix. But knowing what to call it and knowing how to solve it, knowing the name of it isn't going to help you solve it. Okay. Now, what you want to do is get zeros everywhere except here. And I don't care, we put this line here because I don't care what happens to the right. In between this bracket and the vertical line, I want to get zeros except on the diagonal. Now, to get the 2 to be 0, so we want to clean up the first column. Except for the diagonal entry, I want to get everything else to be 0. So I'm going to use the diagonal entry. Diagonal entry in column 1 is in row 1. I'm going to use row 1 to get rid of the 2 in the second row. I'm going to do 2 times row 1, then I'm going to take away row 2. 2 times row 1. 2 times 1, 2, 3. You want to put the line there, no big deal. 2, 4, 6. 2, 4, 6. I just multiplied each entry by 2. And I got 2, 4, 6. And row 2 just stays the way it is. 2, 3, 5. 2, 3, 5. Like I said, I subtract. Because when I subtract, 2 minus 2 gives me a 0. 4 minus 3 is 1. 6 minus 5 is also 1. That is the new row 2. You put a curly marker like that. Row 1, we did not change. Row 2, we did change. It is now 0, 1, 1. Okay. So row 1, see, column 1 is fine. This is the diagonal, and everything else, namely that one entry there, is 0. The column 1 is done. Now I go into column 2. And everything except the diagonal entry must be 0. That is, this 2 must be 0. And I'm going to use the row that has the diagonal entry in column 2. This is the diagonal entry in column 2. So I'm going to use this row. So basically, I am not going to change that second row, but rather I'm going to change the first row. I'm going to get that 2 to become a 0. If you double the second row, then you'll have a 2 here. And you just do row 1 minus 2 row 2. Let's do this on the bottom here. Row 1 is row 1. Row 1 is 1, 2, 3. 2 row 2s. Just double everything in row 2. 2 times 0, 2 times 1, 2 times 1. And subtract. 1 minus 0, 2 minus 2, 3 minus 2 is 1. 1, 0, 1. Now I only care about to the left of that line. Everything other than the diagonal is 0. Namely here and here is 0. Now I want to get what's on the diagonal to be 1. Fortunately, they are. 1, 0, 1, 0, 1, 1. This first equation says 1x plus 0y equals 1. 1x is x plus 0y, but that's just x. 0y is 0. X plus 0 is x equals 1. X equals 1. 1x equals 1. 0x plus 1y. That's y equals 1. So there is the answer. X and y both equal 1. Try another one. Probably easier to do 3 by 3s. But let's do another 2 by 2. 2 equations, 2 unknowns. When I say 3 by 3s, I mean 3 equations, 3 unknowns. Suppose you have that 3x minus 2y negative 3, and that 2x plus y is the number 5. And this is what we want to solve. The first you write down what's called a coefficient matrix. Just write down the numbers. 3, 2. Now this is understood to be positive 1. Negative 2 and positive 1. Then you line for equal. And write down negative 3, 5. In the first column, this is the diagonal entry. That is, we are not going to touch that row. But I want what's above and below it to be 0. Well, there is no above. There's a below. I want that to be 0. So the question is, what is the first common multiple? I want to get the numbers, those 3 and 2's, to be the exact same number. I don't care if the signs are different or not. I want them to be the same number. Well, 6 is the first common multiple between 2 and 3. If you triple row 2, that puts the 6 here. If you triple row 1, that puts the 6 here. And if they're both 6s, then you subtract. 3 times row 2. Just multiply all 3 entries in row 2 by 3. You get 6, 3, 15. Okay, and of course there's a typo here. In row 1 we already have a 3. You just have to multiply it by 2 to get 6. 2 times row 1 is 6. Negative 4, negative 6. And if we want to get a 0 from here, we subtract. 7, 21. 0, 7, 21. Now, it's nice to have smaller numbers compared to bigger numbers. 7 goes into all 3 numbers in row 2. And any row that has that property, you should divide, make the number smaller. I'm going to do row 2 divided by 7. So row 1, we're not changing. If we were, I would write something here. But I did it. I'm only changing row 2. 0, 1, 3. Okay. Now, your book or your teacher might say, oh my, you must get a 1 here immediately. That's not true. That's completely not true. We'll do that in the last step. So we're done with column 1. With the exception of the diagonal entries, everything else is 0. Now we go into column 2. Remember, this is the diagonal. The 1 is the diagonal entry. I want everything else to be 0. Namely, that negative 2. It has to go bye-bye. So what am I going to do to row 1? Well, if you double row 2, that'll put a 2 here. And if you don't do anything to row 1, you'll have a negative 2 here. Well, if you have negative 2 and positive 2, what do you do to get 0? The answer is you add. This time, we are going to add. If the numbers are the same, exactly the same, you subtract to get 0. If they're the same but the signs are different, then you add. Okay, so I don't see anything by row 2. So row 2 is not changing. But row 1 is. Row 1, 2 row 2s. Row 1 is 3, negative 2, negative 3. And 2 row 2s are 0, 2, 6. And we are going to add. And we get 3, 0, 3. 3, 0, 3. Now, we have what I said. Everything but the diagonal is 0. Again, I don't care about to the right of this line. 0 and 0. Now, I want to get 1 from my diagonal. This 3 up here is not a 1. I'll just divide row 1 by 3. That is a 1. And when you divide by 3, you get 1, 0, 1. I think there is a typo somewhere. I copied it down right. 6 minus 6 is 0. 3 plus 4 is 7. 15 plus 6 is 21. Okay, that's right. Oh, okay. 0, 1, 3. So what is x equal? What is y equal? This first line says 1x plus 0y is equal to 1. This 0y is 0. Don't bother writing it. 1x is 1. That means x is 1. The second line says 0x plus 1y, or y, equals 3. If 0x is a 0, so y is 3. And that's your answer. Okay, that's how you do 2 equations, 2 unknowns. I think it might come together better when we do 3 by 3s. Suppose you have x minus y plus 2z is 1, 2x plus y plus z is 4, and x minus y plus 3z is 3. 1 is wrong, and 1 equals 2. Remember, there are understood ones here, 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 and here. Just write down the numbers. 1, 2, 1. Negative 1, positive 1, negative 1. Positive 2, understood 1. Positive 2, positive 1, 3. The line. Then what's called the right-hand numbers. 2, 4, 3. Have some space. I'm going to put that matrix on top. Okay, 1, negative 1, 2, 2, 2, 1, 1, 4, 1, negative 1, 3, 3. These are the diagonal entries. In column 1, I want to get everything else to be 0. I want that 2 to become 0, and below the 2, I want the 1 to become 0. Go column by column. So, if you have 1, and you use the first row, the row that has the diagonal entry. In column 1, the diagonal entry is in row 1. So, if you have 1 and 2, row 2 has a 2, row 1 has a 1. You have to double the 1 and do nothing to the 2. You double row 1 and you do nothing to row 2. And if they're both the same number, you subtract, you get 0. In fact, I'm going to change the problem. I'm going to make this a negative 2. So this happens to be 0 then. Well, if you have negative 2 and you do nothing to it, you get negative 2. You're going to have to add now. Now you're going to have to add to get 0. Now you want to use row 1 to get this entry to be 0. Well, row 1 in the first position you have a 1. Row 3 you have a 1 in the first position. Just subtract. You can do row 1 minus row 3, row 3 minus row 1. Doesn't matter. We're not doing anything to row 1. 1, negative 1, 2, and 2. But row 2 we're playing games with. We're changing it. So let's change it. 2 row 1s. 2 times row 1. 2 times 1, 2 times negative 1, 2 times 2, 2 times 2. I doubled those numbers. Plus row 2. Row 2 is, I guess I didn't double the first number. I said I would. Okay, 2 times, row 2 is negative 2, 1, 1, 0. You want these to give you 0, you add. Negative 1, 3, I meant to say 5. Is it 4? You get 0, negative 1, 5, 4. You got the 0 like you wanted. Now we're going to do row 1 minus row 3. Row 1 is 1, negative 1, 2, 2. Row 3 is 1, negative 1, 3, 3. And you subtract, you get 0, 0, negative 1, negative 1. Okay, 0, 0, negative 1, negative 1. So I am done with column 1. When it comes to column 1, other than the diagonals, the diagonal entry, I have zeros. Now I go into column number 2. Here is my diagonal entry. I want what's above and below to be 0. Fortunately, what's below is 0. So above, it's a negative 1. Well, if they're both negative 1, elementary school subtraction or algebraic subtraction, high school subtraction will kill it off. Here is row 1. Here is row 2. You subtract, you get 0 there. Okay, so let's write up the new matrix. And column 2 is done. It's easier to get rid of to clean up column 2 because we already have a 0. So row 1 is now 1, 0, negative 3, negative 2. Row 2 did not change, and row 3 did not need to be changed. Now we go into column 3. This here is the diagonal entry. So I want what's above it to be 0. There are no belows. If there were anything below, it would have to be 0. Well, negative 3 and 1. I don't see signs. The least common multiple will be 3. If you multiplied row 3 by 3, this will be a negative 3. If you don't do anything to row 1, this is a negative 3. If they're both negative 3, subtract, you'll get 0. Okay, now what do we do to row number 2? I have 5 and 1. The first common multiple will be 5. If you don't do anything to row 2, you have 5 or maybe negative 5. I don't care about signs yet. And if you multiply row 3 by 5, you'll get a 5. Well, now let's talk about signs. If you don't do anything to row 2, you have a 5. And if you multiply row 3 by 5, you get a negative 5. You have to add to get 0. You have to add. Okay, let us do this arithmetic. That'll be it. Let's do this arithmetic. So we are messing with row 1 now. Row 1 is just 1, 0, negative 3, negative 2. 3 rows 3's are 0. Row 3, 0, 0, negative 3, negative 3. If you want this to be 0, you subtract. 1 minus 0, 0 minus 0. Negative 2 minus negative 3 is 1. So you get 1, 0, 0, then 1. Now, row 2, 5 rows 3's. Row 2 is 0, negative 1, 5, and 4. 5 rows 3's are 0, 0, negative 5, negative 5. And if you add, this gives you 0. 0 plus 0, negative 1 plus 0, 5 plus negative 5. Excuse me, negative 1 plus 0 is not 0. It is negative 1. And 4 plus negative 5 is negative 1. 0, negative 1, 0, negative 1. In row 3, we don't change. Other than numbers on the diagonal. When I'm talking about numbers, I mean to the left of this line. Numbers other than the diagonals are all zeros. That means we are 99% done. We have one more step, possibly, that needs to be done for the matrix. And that's to get ones on the diagonal. I say possibly one more step, because if they weren't already 1s, we wouldn't have to do this step. But we do. In row 2, we have a negative 1. Well, multiply row 2 by negative 1. Or divide by negative 1. Multiply row 3 by negative 1. You can write negative 1 row 2, or just negative row 2. It means the same. The first row stays the same. The second row, you multiply each entry by negative 1. That means you change the sign. And in row 3, we multiply by negative 1. And now we could write down the answers. 1x, or x, plus 0y, which is 0, plus 0z, which is 0. X plus 0 is x, equals 1. 0x, which is 0, plus 1y, which is y, plus 0z, which is 0. When you add those, you get y, equals 1. 0x is 0, plus 0y is 0, plus 1z is z. And this equals 1. So there's the answer. X, y, and z, they both equal, they all three equal 1. It's a coincidence. Okay, let's try one more. That's my answer. X minus 2z is 7. Y plus z negative 1. And x plus y plus z is 0. Now, you have to understand that in equation 1, is an understood plus 0y. You can add 0 anytime you want. And in equation 2, you can add 0 again, it's 0x. And in this third equation, there's no modifications to do, other than maybe to save it once. So, I can write down the augmented matrix by using just the coefficients. 1, 0, 1, 1, 0, 1, 0, 1, 1, 0, 1, 1, negative 2, 1, 1. The right-hand side is 7, negative 1, 0. This is the right-hand side. And there is our matrix, our augmented matrix, and we are going to solve this. You go to column 1, and you locate the diagonal entry. Remember, these are the diagonal entries. In column 1, it's step 1. So I want above and below to be 0. There is no above, so I want what's below to be 0. Fortunately, that is a 0. That saves a little time. So I want this 1 to be a 0. If they're both 1s, just subtract. You can do row 3 minus row 1, row 1 minus row 3. Doesn't matter. What does matter is that the first row did not change. The second row, we didn't need to change. The third row changed. 1 minus 1 is 0. 1 minus 0. Row 3 minus row 1 is 1. 1 minus negative 2 is 3. 0 minus 7 is negative 7. And if you can divide any row by a number and make them smaller, do so. But I don't see that happening. Okay, column 1 is fine. Column 2. This is our diagonal entry. I want this to be 0 and that to be 0. Well, first, fortunately, this is 0. So we just have to get this 1 to be a 0. And since they're both 1s, why don't we just do row 3 minus row 2? So row 1 didn't need to be changed. Row 2, we never really planned on changing it. Row 3. Here is row 3. Here is row 2. If you happen to subtract, you get this. 0, 0, 2, negative 6. And here's a case where I can make the numbers smaller by dividing. In row 3, all the numbers are even. You can divide by 2. Row 3 divided by 2. So row 1, no need to change. Row 2 does not change. Row 3 is that. Divided each of the 4 entries in row 3 by 2. Third column, that's the diagonal entry. Using row 3, I want to get what's above this 1 to be 0. Well, negative 2 and 1, 2. Or 2 and 1, 2. We already have our 2 here. I don't care if it's plus or minus. I'm not going to do anything to row 1. And to get a 2 down here, I'm going to double row 3. Now we're talking about signs. Row 1 is negative 2, and 2 row 3s will give me 2. To get a 0, I have to add. Okay. Now I want to get this 1 right here to be 0. Well, they're both 1s. The diagonal entry and the number above is 1. I'll just do row 2 minus row 1. Okay, we do our arithmetic, and everything off the diagonal will be 0. Row 1 is 1, 0, negative 2, 7. 2 row 3s are 0, 0, 2, negative 6. If you add, you get 1, 0, 0, 1. Okay, that's the new row 1. 1, 0, 0, 1. Row 2. Row 2 minus row 1. Minus row 3, excuse me. 0, 0, 1, negative 3. If you subtract, you get 0, 1, 0, 2. Okay, 0, 1, 0, 2, and row 3, we didn't change. Okay, now, with the exception of diagonal, everything is 0. With the exception of the diagonal, everything else is 0. Everything else is 0. Of course, I'm not talking about to the right of this line. Okay. Now I want to get what's on the diagonal to be 0. In row, to be 1. Excuse me. In row 1, it is 1. In row 2, it is 1. In row 3, it is 1. X equals 1. Y equals 2. Z equals negative 3. Exactly what I said the answer would be. X is 1, Y is 2, Z is negative 3.